question which has been asked in JEE Advanced. We cannot take that question in easy way. We can't assume that this question can be done in 3 or 4 minutes. Generally, JEE Advanced question may take around 10 to 12 minutes. So this is a question from the chapter Functions. Chapter Functions. There is a question which is given to us. A function f is defined from 0 to 1 to r, and fx is given to us 4 raised to power x divided by 4 raised to power x plus 2, and there is a sequence given to us which is containing 39 terms, and there is one more term, that is f of half. So there are 4 points which I observed in this question. First is that domain is given to me from 0 to 1, right? So I have to see that the value which I can put x, values of x which I can put should be greater than equal to 0, less than or equal to 1. Value of x should be between 0 to 1, and here I observed that all the values which have been put here in place of x are all less than 1, lying between 0 to 1. 1 by 40 is a number which is greater than 0 and less than 1. Similarly, 39 by 40 is also less than 1 but greater than 0, and f of half means half, if half is also greater than 0, less than 1. So all the values are lying in the domain between 0 to 1, and the function which I observe here is 4 raised to power x divided by 4 raised to power x divided by 2. And third is, this is a series of 39 terms, and my fourth observation is that f of half is also there, but sign is negative here. Sign is negative here. So I have observed 4 things here. One is domain, second is the definition of the function, third is the series, pattern of the series. There are 39 terms initially, and then one more term is there, that is f of half, but sign is negative. So when I go in more depth of this function, I observe that 4 raised to power x whole divided by 4 raised to power x plus 2 means this is a function of type that a raised to power x, where a is a constant which is here given to us 4 whole divided by a raised to power x. Here 4 raised to power x is repeating, so I am also repeating here a raised to power x divided by a ki power x plus 2. 2 can be written as square root of a. So this is a special type of function. If you have studied function, you might have seen such type of functions, and in this type of functions we generally observe that ki if I replace 1 minus x in place of x, then what will I get? I will get a raised to power 1 minus x whole divided by a raised to power 1 minus x plus square root of a. If this is fx, a raised to power x divided by a raised to power x plus square root of a. If I add both of these, f of x plus f of 1 minus x, this is a special characteristic. I observed it on the basis of the definition of the function, because function is of this type. When I add both of these, I found that a raised to power x divided by a raised to power x plus square root of a. This is my fx plus I will put now f of 1 minus x, and f of 1 minus x is given to me this expression a raised to power 1 minus x divided by a raised to power 1 minus x plus square root of a. When I get simplified it, I found that I can write a upon a raised to power x. Similarly here a upon a raised to power x. When I take LCM, a raised to power x in denominator, I will find square root of a into a raised to power x. Is it okay? a रेस टू पावर एक्स एलसीएम जो लिया वो कैंसिल हो गया हमारा न्यूमरेटर और डेनोमिनेटर का। जो डेनोमिनेटर में a की पावर x था वो कैंसिल हो गया हमारा. आई होप इट इज़ क्लियर टू यू. नाउ आई कैन सी that in next step I can write a raised to power x divided by a raised to power x plus square root of a plus a divided by, if I take square root of a common here, if I take square root of a common here, which is common because I can take a and square root of a, I can take root a common, then I will find that root a here plus a raised to power x here. So what I see that denominator are now same. In next step I can say that this a and divided by square root of a. So square root of denominator, square root of a in denominator will be cancelled out, right? So this becomes square root of a in numerator. Now I can see that denominator are same in both the expression, a raised to power x plus square root of a. Now I can take LCM, a raised to power x plus root of a, and I found that in numerator as well, a raised to power x plus square root of a, and both can be cancelled out, here because both are same. So I find 1. So I observed that here in this function also I will find that here this condition will also be true, that f of x plus f of 1 minus x will be 1. So this is my important conclusion in such type of questions. I observed the function, I observed the characteristic of the function. Here in place of a, 4 was there, so 4 raised to power x plus 4 divided by 4 raised to power x plus 2. When I will replace 1 minus x in place of x, I can easily understand that when x is between 0 to 1, then 1 minus x will also be between 0 to 1. We can understand it because x is positive between 0 to 1, domain is this. So before putting 1 minus x, I have to check the domain. So here value of 1 minus x will also be between 0 to 1, because when I will put 0 in place of x, I will find 1 minus x as 1, and when I will put x equal to 1, then I will find 1 minus x equals to 1 minus 1, that is 0. So extreme values are 0 and 1. When I put x equal to 0, then I found that 1 minus x is 1, and when I put x equal to 1, then I found that 1 minus x is 0. So I can say कि 1 minus x is lying between 0 to 1. So I can put 1 minus x in place of x whenever required. So this is my important conclusion. If you can understand कि f of x plus f of 1 minus x I got equal to 1. Addition of these two numbers is 1. So I derived it and I got that it is coming out to be 1. I hope till now it is clear. Now we will move further toward the solution of this value of this expression, which is a series of 40 terms. Now I will see these 40 terms closely. I have observed domain, I have observed the function, definition of the function, special type of function, and then I have concluded that fx plus f of 1 minus x is 1. Now I will write this sequence on next page. So let us see. I will write here required expression to find. It is required f of 1 by 40 plus f of 2 by 40 plus f of 3 by 40 plus f of next will be 4 by 40 till I will find f of 39 by 40. These are 39 terms. These are 39 terms in the question given to us from 1 by 40, 2 by 40, 3 by 40 till 39 by 40, and in last f of half is given to you. So minus f of half I have written here. So let me assume this value as y. Now I will find the value of y. So before going forward, I observed that there are 39 terms containing 1, 2, 3 up to 39 in every term divided by 40. So these are 39 terms. So in between these 39 terms, I can say there will be a term, first is 1 by 40, last is 39 by 40. Definitely a term will be there which will have 20 by 40, right? If I see in the right side of it, the next term will be 21 by 40, and in left hand side of this will be 19 by 40. So I can say out of these 39 terms, so pattern is like this, shown here, shown in left or right. In right of 1 by 40, next will be 2 by 40, and in left of 39 by 40, 38 by 40 will be there. So these are total 39 terms, f of 1 by 40, f of 2 by 40, f of 3 by 40, f of 4 by 40. So I am observing the values of x which are written here. In place of x it was 1 by 40, then 2 by 40, so on. Here it will be a term containing 20 by 40, right? So this is the middle term. I can say that 20 by 40 will be middle term, and 20 by 40 can be written as half. 20 by 40 can be written as 1 by 2, right? So I can say this term is f of 1 by 2. Just right of it is 21 by 40, next will be 22 by 40, and last will be f of 39 by 40. So this is the pattern which I observed. First is 1 by 40, second is 2 by 40, so on. So out of these 39 terms, one is middle term. So if I observe it, so this is same as that of this last term. You can see this last term, this is also f of half. So I can say this f of half and this f of half will be cancelled out. So I will not do any calculation for it, I will first cut it. So initially I observed this question and I got that there will be a term containing f of 20 by 40, and 20 by 40 means f of half, so f of half and f of half will be cancelled out. So I can do cancel these two terms, f of half and f of 1 by 20 will be cancelled out. Now remaining is, this is my y which is required to find, this is my y, and in this series I can say out of 39 terms, these were initially 39, one cancelled out, so now 38 terms are there, 38 terms. So if I divided by 2, so I found that there are 19 terms. Just prior to f of half, it was f of 19 by 40, and just right of half, that was f of 20 by 40, f 21 by 40 is there. So I have decided to understand that f of 19 by 40 and f of 21 by 40. I hope everyone is comfortable. So it is clear now. I have divided these 38 terms, these are 38 terms, in two parts. First part till 19 by 40 and second part from 21 by 40 to 39 by 40, means 21 by 40, 22 by 40 till 39 by 40. These are 19 terms, and from beginning 1 by 40, 2 by 40, 3 by 40 up to 19 by 40, these are also 19 terms. So these 19 and this 19, and middle term, that was f of half, that has been deleted. So first half is first 19 terms, second half is second 19 terms, remaining 19 terms. Now let us see what happens. Now it is obvious. What obvious? Obvious is this, that if I assume x as 1 by 40, then 1 minus x will be equal to 1 minus 1 by 40, means 39 by 40. So this is my observation. So when I will find f of x, means f of 1 by 40, and whenever I will require f of 1 minus x, means f of 1 minus 1 by 40, means f of 39 by 40. So if I associate f of x plus f of 1 minus x, I have concluded that the value of this will be 1. So I need not to check again. Still you find, you can check f of 1 by 40 plus f of 39 by 40 will be 1, I can say. Similarly, if I take second term, that is 2 by 40, and second last term will be here 38 by 40. I can say that if I take 2 by 40 as x, then 1 minus x will be equal to 1 minus 2 by 40, that will be 40 LCM. So 40 minus 2, 38 by 40. So I can say ki f of 2 by 40 plus f of 38 by 40 will also be 1. So on, I can say till f of 19 by 40 plus f of 1 minus x will be 21 by 40. Complementary, we can say, complementary, x and 1 minus x are complementary, we can understand. So each I will make pair of first and last, second and second last, and 19th to 21st term. So second last term with second term, and 19th term with 19th term from the end, or you can say 19th term and 21st term will be clubbed together. So I can say, if I make pairs like this, 2 pairs in each, so such 19 pairs will be formed. First pair will contain f of 1 by 40 plus f of 39 by 40, and last pair will be f of 19 by 40 plus f of 21 by 40. So these 19 pairs will be formed, and each pair will give me one answer. Outcome will be 1. So such 19 terms will be there. So 1 plus 1 plus 1 plus up to 1. How many terms are these? 19 terms. 19 terms are there. So I can say answer will be 1 into 19. So 19 is my answer. So this was integer type question, and we can conclude that answer is 19 here. So this was a good question, very interesting conceptually. So whenever you will do such type of questions again and again, you will be able to find the approach in examination as well. So keep doing such type of questions, and if you have liked this explanation, this question, then please like and subscribe and share with your friends. Thank you.